prove from first principles. You will end up with the function u equal to a function in x. Then from first principles, the u of x plus h will become the x is replaced with x plus h. Then the u of x plus h minus the u of x, if I subtract them, is the u of x plus h minus the u of x. Yes? And if I divide all that by h, and I get its limit as h goes to infinity, well then that becomes du dx. In other words, what I'm saying to you is every time you come across du dx is the limit as h goes to infinity of the u of x plus h minus the u of x over h. If I come across that, what can I call it? Du dx. Yes? If I come across the v of x plus h minus the v of x all over h, if I come across the limit as h goes to infinity of that, what can I call it? No, if you don't understand, you can't do anything. You can't prove any of the rules unless you understand that. Anytime you come across that, it's replaced with the u of x. And anytime you come across that, it's replaced with the v dx. And what book is this in? Book 1, I think, is it? I'll just look at the theorems you have to prove, just how they write them. Alright.
So I don't understand how just making h go infinity into turn into du dx.
Well, that's how you differentiate from first principles. Look up here at this board. You first of all get the f of x, then you get the f of x plus h. Then you get, it's the limit as h goes to 0, is it not? Huh? It's the limit as h goes to 0. I beg your pardon. Yes? And that's what it is. Then you get the f of x plus h minus the f of x. Then you divide it by h, and then you get the limit as h goes to 0 of it. And that's how you differentiate from first principles.
But sir, wouldn't h going to 0 be impossible, so you can't put anything over 0?
So you don't understand what's happening. Therefore, if I have a curve,
so it never actually gets to 0.
If I have a curve and that is the point on the curve xy, and I want to get the slope of the tangent to that curve, if I take my other point to be there, I don't exactly have the slope of the tangent to the curve. Now as this point gets closer to this point, I'm nearer to having the correct slope. Yes? So therefore, as the difference between this point and the next point becomes 0, dy dx I'm getting more accurate. Whereas if the other point is up here, if I took them 2 points, that's not the slope of the tangent to the curve. That's where my h becoming 0 comes from. Alright? Okay, so my theorems. The first theorem they want you to prove is theorem 1. If f of x is equal to the u of x plus the v of x. What that means, if I have a function in x plus a second function in x. So if y was equal to x cubed plus 2 sine x, how do I differentiate that? Well, I differentiate the first one, 3x squared, and I differentiate the second one, 2 cos x. So what I'm telling you is if there's a sum, I have to prove that the answer to that is the derivative of one plus the derivative of the other. So from that I get the f of x plus h. The f of x plus h is the u of x plus h plus the v of x plus h. And then I must work out the f of x plus h minus the f of x is equal to the u of x plus h plus the v of x plus h minus f of x, the u of x minus the v of x. That's the same thing as the u of x plus h minus the u of x plus the v of x plus h minus the v of x. And then I must work out the f of x plus h minus the f of x, and I must divide it by h. Now when you're dividing by h, when they're added up, subtracted, what must you divide h into? Everything, yes? Okay? So they're added, it's the u of x plus h minus the u of x plus the v of x plus h minus the v of x. I must divide that by h. Because they're all added and subtracted, h is divided into every single one of them. And then I must get the limit as h goes to 0 of the f of x plus h minus the f of x all over h, which is equal to the limit as h goes to 0 of the u of x plus h minus the u of x over h, plus I can say it's the limit as h goes to 0 of the v of x plus h minus the v of x all over h. Now what can that be replaced with? Du dx. And what can that be replaced with? dv dx. So there's your first theorem. If they are added and subtracted, when you differentiate them, what do? You differentiate one and you differentiate the other. Any questions there? Sorry, let me zoom in focus. Have you any questions about that one? So that's your first theorem. Now, the second theorem is where the maths is involved. If f of x is equal to the u of x times the v of x, in other words, this is the product rule. Yes? Well then, what's the f of x plus h equal to? It's the u of x plus h times the v of x plus h. And then what's the f of x plus h minus the f of x equal to? It's the u of x plus h times the v of x plus h minus the u of x times the v of x. Is that alright? Now what you do now is the secret. You know the answer has to be u dv dx plus v du dx. Yes? How do you get dv dx? It's x plus h, it's v of x plus h minus the v of x over h. So look at, you have to add in. It becomes the u of x plus h times the v of x plus h. And I must put into that plus, right, if I need plus du, it's minus du of x plus h times the v of x. Now look what has happened here. I had a u of x plus h here, so I put it in here again because I need the v of x plus h what? Minus the v of x. Now where did that come from? I added it in new. Yes? So to balance that I must have plus the u of x plus h times the v of x minus the u of x times the v of x. Why did I add that? Well now what can I do? I can factorize that. The u of x plus h out, and what will I have inside? The v of x plus h minus the v of x plus, what is common here? The v of x. And what will I have inside? The u of x plus h minus the u of x. Because what's that going to become? dv dx. And what's that going to become? Do you know how I understood to add that? Because I needed the v of x plus h minus the v of x. Why did I need the v of x plus h minus the v of x? That's how I get the v dx. So, what did I have to add on new? Well, I needed a v of x, and that had to be the same as that to allow me to do what? To factorize. Now, if you sit there and don't understand, it's little I can do for you. The next step then is the f of x plus h minus the f of x all over h, which is equal to that all over h. And then I need the limit as h goes to 0 of the f of x plus h minus the f of x all over h, which is equal to the limit as h goes to 0 of the u of x plus h times the v of x plus h minus the v of x all over h, plus the limit as h goes to 0 of the v of x times the u of x plus h minus the u of x all over h. Now, because they're added, h had to be divided into both of them, correct? Because they're multiplied, h is divided into how many of them? 1. So what's the limit of that? So it's the u of x by the v of x plus the v of x by u by dv dx plus the v of x by du dx. And that's your product rule. Because why is this not the u of x plus h? What does h become? 0. That's your product rule. Now, if you look at a book, you'll go from that line to that line. You won't have a clue where that came out of. Do you understand it was added in? And if that was added in, why was that put in? To balance it. Yes? Product rule. Quotient rule. F of x is equal to the u of x divided by the v of x. The f of x plus h is equal to the u of x plus h divided by the v of x plus h. The f of x plus h minus the f of x is equal to the u of x plus h over the v of x plus h minus the u of x times the v of x. Better subtract them. I'll get the u of x plus h times the v of x minus the u of x times the v of x plus h all over the v of x plus h times the v of x. U dv dx. All I did there was got an LCM. Is that okay? Yes? So the v, that divides the v of x times, so I get that. Now, what do I need to add in u? Well, the formula has to say v du dx minus u dv dx all over v to be squared. V, so I need the v of x. So I have the u of x plus h times the v of x. What do I need to add to that? Minus the u of x by the v of x. Do you understand why I knew to add that in u? Because what will happen to v of x? Factorize out. And what am I left with? The u of x plus h minus the u of x. So to balance that, plus the u of x times the v of x minus the u of x times the v of x plus h all over the v of x plus h times the v of x. So if I divide h, I have to divide h into both of them. So if I take, what will factorize out here? The v of x outside of the u of x plus h minus the u of x. That's that. Now, they take out minus the u of x. And what will you be left with? The v of x plus h minus the v of x all over the v of x plus h times the v of x. Divide by h, what will that become? du dx, that? dv dx. So what will you get? v du dx minus u dv dx all over v to b squared. But do you know where that came out of? Now you'd be some Amadon if you went around learning off the u of x minus the v of x, the u of x minus the v of x, the u of x minus the v of x. You'll have some nice time between now and the end. A lot of people really don't understand that anytime you come across that it's the u dx, and anytime you come across that it's the v dx. Yes? And then your final theorem is the proof by induction. That if y is equal to x to the power of n, that means that dy dx is n times x to the n minus 1. So you prove for n equal to 1. So if y is equal to x to the power of 1, well then we know that dy dx is equal to 1. And if y is equal to x to the 1, we're saying dy dx is equal to once x to the power of 1 minus 1, which is once x to the 0, which is once 1, which is 1. So therefore, what can we say that it is true for n equal to 1? 2. I assume that it's true for n equal to k. So therefore, what am I assuming? I'm assuming if y is equal to x to the k, well then dy dx is equal to k times x to what power? K minus 1. And 3, I must prove now that it is true for n equal to k plus 1. I was enjoying myself. Is it long gone? Did you tell me in time? You did. So prove it's true for n equal to k plus 1. In other words, what am I trying to prove? If y is equal to x to the k plus 1, then I'm trying to prove that dy dx is equal to k plus 1 times x to what power? K. Yes? So, yes. If y is equal to x to the k plus 1, I'm saying that means y is equal to x to the power of k by x to the power of 1. And then dy dx is equal to the derivative of, it's the first by the derivative of the second, by 1, plus the second by the derivative of that, k times x to the k minus 1. Now how do I know that's true? I've assumed it true in part 2. So that's equal to x to the k plus x by x to the k minus 1. It's k times x to the k minus 1 by x to the 1. What do we do with them when they're in that form? You add the powers. So it's k times x to the power of k. Take x to the power of k outside, you'll have 1, and here you'll have k. So it's equal to k plus 1 times x to the power of k, which is true. And there are your theorems. And that isn't a great focus. So you have to know all of them. That's the old course. There? Is that better? Huh? So, there are your theorems. So, what do you need to know as a student? Well, first of all, if you don't know that, you're not going to be able to do any of them, right? If you don't know that that's the u dx and that's the v dx, you're finished. Then after that, you have to be able to do the sum or difference, the product rule, and the quotient rule. And then your proof by induction. Now, do you want to start making a few notes? I suggest that you begin with that note there. Bye.